We started to test �11𝗿𝗁 last year in a beautiful data set that was donated to us by TGS, the West Lindsey project. And I simply had a question. I said, look, I've already done a fault interpretation on this manually. So how good is �11𝗿𝗁 in being able to come in there and run its convolutional neural network fault detection and identify the faults that I can then compare to my original interpretation? So I'll quickly step through these slides. We have this fault framework integrated into the cross-section. There you see the faults that were calculated and identified by the �11𝗿𝗁 software. Right? And then I show the actual seismic. And then we show these faults extracted as three-dimensional surfaces. And then we can color them by different parameters, such as the size of the fault, the aerial extent, as well as the confidence of the fault, and then filter it down to the faults that we know we are the most confident in, that have been properly predicted. And these are the faults right there. Now, that surface that you see in color is a very important surface. It's the basement surface. So if you do any sort of research on saltwater disposal or earthquake occurrences in the Delaware Basin, it's all linked to the faults that are rooted in the basement. So it's very nice that these faults were identified by �11𝗿𝗁. And if I then look at the prior fault interpretation, you can see that they match extremely well. So that gave me a lot of comfort. It basically proved to me that �11𝗿𝗁 is able to interpret all of the critical faults rooted in the basement automatically and a lot faster than what I had to do using the manual fault interpretation. Because now I could take the �11𝗿𝗁 faults, integrate them into my actual three-dimensional model, start building a layer model, and then create a three-dimensional volumetric model of this part, this section of the southern Delaware Basin. And then apart from actually comparing it with my original interpretation, I can also compare it with larger scale regional faults that were obtained for many different sources. So this is an incredibly fast way to go interpret your faults and build your three-dimensional subsurface model.